Hello everyone and welcome back to my channel. I want to let you know that I am working on my Patreon channel and you will find this video there as well. And I will write an ebook on how to get started with 3D measurements. This will be free for my subscriber in the XYZ Architect Patreon channel. I repeat, I am working on the book and it is not available for the moment, but it will be in the future. Okay, today we are going to talk about perpendicularity, so let's get right to it. Perpendicularity is a geometrical characteristic that is frequently found in our day-to-day work as measurement engineers or technicians. And the definition for it can be something like this. Perpendicularity is the condition of a surface, a line or a median plane to be exactly at 90 degrees from the reference plane or reference line. And here we have the symbol for the perpendicularity. Just some words from me until we continue. So, as it says here, my real name is Marius. I'm the founder of the XYZ Architect concept. So, XYZ Architect is my passion project. It's my way of giving back to the community what I know and my way of making this domain a great one to work in, with lots of good people. We intersect each other's work lots of times, so I think that we should speak the same language when we come across one another. And yes, it's good to be in this community of people that want to develop a good work ethic and are in permanent search of knowledge. How to give you some knowledge and peace of mind. And remember that I do research for all my videos in order to keep you well informed. It's good to know some history about the things that we learn about. So I found out that perpendicularity is original from Old French and it was called perpendicular. The meaning perfect vertical is by 1590s and it was described as a line that meets another line or a plane at right angles first in 5070s. It was first used in astronomy as the line lying at the right angles to the horizon. Unfortunately, I did not find any information about the founder of perpendicularity, but whoever he is, I am grateful that this geometrical characteristic exists and that it helps me to check the products that I measure every day. We have to know about the tolerance of the perpendicularity and the way we can interpret what we read from the drawing. So the perpendicularity tolerance represents the maximum admitted value from the perpendicularity deviation. We have the simple perpendicular tolerance. This tolerance is limited by two parallel planes or lines at a distance t apart and perpendicular to the datum axis or surface. We can have the perpendicular tolerance with the symbol of the diameter next to it. This means that the tolerance zone is limited by a cylinder or diameter t perpendicular to the datum. And we can also have the perpendicularity with the symbol of the diameter next to it, but also with the symbol of m, which means that it can be maximum material condition and it can have a bonus tolerance. And we have four types of perpendicularity. Depending on the features from the parts that we are measuring, we can have an axis perpendicular to another axis, an axis perpendicular to a plane perpendicular to an axis, or a plane perpendicular to another plane. If you managed to stay until now, please make sure to hit that like button for the algorithm to work and subscribe if you like my content. I've also made some examples for each type of perpendicularity to understand what the designer of the drawing wants us to measure, when he represents these characteristics in the drawings. And for our first example, we have two cylinders that are perfectly 90 degrees one from another. So we have two medium lines, and we can see in the section from the drawing that the cylinder from above has a perpendicularity specification from the cylinder from below. That is reference A. So how to interpret the drawing specification? Since we know what we need to measure and where the reference is, we can imagine that the total tolerance zone of 0.06 millimeters and the length of the cylinder, it's better to have the length of the cylinder because we will measure the whole length of the feature and not some of it. And we know that we want our feature to be at 90 degrees from the reference. Knowing this, we can now go and measure our elements and evaluate the perpendicularity. In our second example, we have two different features, a cylinder and a plane. So we have an axis perpendicular to a plane. In the section from the drawing, we can see that the cylinder has to be perpendicular to datum A. We can interpret this by imagining the total tolerance zone as a cylindrical tolerance zone where the median line of the cylinder has to lie, in order for it to be perpendicular to the reference plane. Now we can measure our feature and evaluate the perpendicularity. In the third example, we have a plane perpendicular to a cylinder. So we have an axis as the datum, and we can also see in the section from the drawing that we have the plane that is constrained to the axis with a tolerance of 0.018 perpendicularity. We can interpret this if we imagine our plane lies between two other planes with a distance of 0.08 millimeters between them and a perfect 90 degrees angle from datum A. Now that we have this in mind, we can go and measure our features and evaluate the characteristics. And in our final example, we have two similar features, more precisely two planes, and the one from the right has to be perpendicular to the one from the bottom. We can also see this asking in the section from the drawing, right here. So in order to interpret our example, we have to imagine that our plane from the right side lies between two parallel planes with a distance between them of 0.08 millimeters and an angle of 90 degrees from the bottom plane, that is our reference A. I also selected three real-life examples where perpendicularity is required. Connectors. Notice how the plane from the front of the connector is presented at 90 degrees from the plane at the top of the connector. Here we have a classic perpendicularity requirement. Also, for this connector, the cylinder where the counterpart connects has to be perpendicular to the interior plane. That we cannot see, but we can imagine where it can be. Turbines. The cylinder from the turbine is most certain the reference, and all the parts that come on top of it has to be perpendicular to it in order for the rotation to be circular. Syringes. The top pipe of the syringe has to be perpendicular to the interior plane in order for the liquid that comes through it to go as desired as we push the counterpart from here to here. Thank you for watching, see you next time. And if you want to see a practical example on perpendicularity, go check out my video in the description below on perpendicularity on GOM Inspect.